Hi everyone, I hope you're having a wonderful weekend. We have spring break coming up in a week. So what you're going to notice is that the assignment for this week's chapter will be due not this coming Sunday, but the one after. So you have an extra week to complete those assignments. So we are continuing with our, so we're on it's showing unit 2 right now, but as you know, we just had our second exam for unit 2, and we are continuing with our unit 3. So we have thermophysics that's due tonight, and we're going into electricity. You can see that, everything is organized just like any other chapter, but we're going to take a quick look to see what we're talking about. So electricity is this chapter 9, and as you very well know, this is something that you use every day, and we have so many applications. And it's also a very vast chapter, so really hard to cover in just 1 week. But that's also the case with all the other chapters that we're covering this semester. So we are going to focus on some particular topics, starting with essentially like where it's, where it all comes from, with the concept of electric charge. And so it's one more thing that we're going to be able to use to describe an object. So just like we've used, the mass of an object, we can also assign it an electric charge. And so we'll see that we have objects that can be neutral, positively charged, or negatively charged. And we'll see how they interact. So the interactions for electric charges are governed by Coulomb's law, and so we'll learn more about that. We will go into the idea or the concept of an electric field. So this is going to be somewhat similar to a gravitational field, except that now we're focusing on that electric charge. And we'll see that this has essentially, this is consequences in terms of, how we use electricity, where it comes from. So from these concept of electrostatic force and electric fields, we're going to see how we can see the concept of current emerge, and essentially looking at some simple circuits, how we can build simple circuits, and also applications in our everyday life, specifically things to look out for when we are close to electricity, and things to be careful about, but also useful concepts like understanding how to read your electricity bill, right? And how we measure our electricity consumption and where it may come from. All right. So again, a very vast chapter once again, but a very important one. And so in terms of structure, you're very well used to how things are organized in this course by now. So lots of different videos to guide you here. Then we go into the pre-chapter check. So I'm going to skip over that. You can also skip over if you want. Again, this is not something that's for credit. And then here we have our lecture videos. So you can see that the first tab is focusing on, electric charge, electric force, and electric field. So that's what I had just mentioned. And then beyond that, here on the second tab, we talk about electric potential and electric potential energy. So those are two separate things. But with this, we're going to start talking about circuits, because you'll see that this is essentially that energy and what you need to start like getting that current in your circuit. So then we go into electric circuits. We're going to look at some simple elements that you can see in electric circuits, and we'll talk about electrical safety and power. So again, very important topics. I also want to point out that you have one last tab that shows you additional help. So these are some problem solving videos, and so if you're stuck on some questions, you can come here and check if maybe I actually solve that question for you and show you the step by step. All right, so after that, it's showing our homework, and finally the discussion for this week. This one is focused on 3 different simulations. They're fun ones. I would encourage you to explore all 3. And in your post, you can talk about one specific one out of the 3. So you can pick your favorite one and share out, what you learned, something that you noticed, and make sure, as always, to share with the rest of the class. So you can see the 3 are called, so they're all PHYS simulation. One is called balloons and static electricity. This is something you can actually try it at home if you have a balloon, but we'll see that this shows explicitly the charge, because in real life we don't get to actually see that. The other one is called electric fields of dreams, and the last one is called John voltage, and it will become clear why in a minute. So let's start with balloons and static electricity. So with this simulation, you have essentially this image of, so you have a sweater here, you have a balloon, you can see that over here we have a wall, and we see electric charges here. Essentially, like, that is to show sort of the charge that's in the molecules that make up all of these things. Everything is neutral right now, because for each positive charge you have a negative charge, so those two cancel out. You can change the settings to not see the charges, but it's sort of the point here, right? So it's kind of nice to be able to see the charges, but if it's overwhelming to see all of them, you could just show the charge differences, and you can check, right, if you don't want to count all of the charges, that it is indeed neutral right now because there's no differences. Now what we can do is actually take our balloon, and if you've ever played with balloons before, you can see that once you can use friction to pick up the negative charge from the sweater and put that on the balloon, and that's going to change that's going to change what happens with the balloon here. So you can try to figure out, so observe what's happening with the wall, you can observe what's happening with the sweater, and share out. So again, you can try different things. You can reset the balloon, you can have more balloons, you can try different experiments with this one. The second one was that electric field of dreams. So this one seems kind of, it's like a box, right? Essentially you can add a charge. You can check out the properties. It's showing over here. So this one is kind of simple, but you can see that the properties of the charge, so this is an electric charge that we added into this square. The charge is -1, so it's a unit of charge here. We'll see in this chapter that typically we measure our charges in coulombs, and so anyways, you learn more about that. We're given a mass. And so this could be something like an electron, for example. You can change that, you can make it positive, you can add more, remove, etc. What this is showing you here is the electric field that is generated by the charge. So all of these arrows are pointing towards our negative charge, and it tells us that that negative charge is generating an electric field that is radial, so it's pointing towards the charge, and again pointing towards it, and it's so it's a spherical symmetry, but this is kind of beyond. But you could change this, and so it's loading and add. So I actually added another negative charge, but you can essentially, there's a number of things that you can try out. And now that I added a second one, you can see that they're interacting with each other. We have two negative charges in the plane, and what we'll learn is that opposites attract, but like charges repel, so they're trying to get away from each other, but they're stuck in this square. So again, you can try out different things and share out with the group. And that's the last one, so John Travoltage. And with this one, you can see that, so John is sitting on this rug, and just like with the balloon, you can essentially use friction and pick up some charge from the rug, and then we can also move the hand, and I'll let you figure out what happens when you touch this metal doorknob here. But so this one is a fun one, but again, this is to also help see those charges, because otherwise these concepts are very abstract because we don't see. I mean, we sort of see electricity, we get the sense that we see electricity when we see lightning and things like that, but we don't really, so getting a sense of how this all works is really helpful. PHYS also has simulations for circuits, and so yeah, check those out. Again, this is something that's around us. We are, as you're watching this from your computer, you're using these circuits all the time. All right, so I'll stop here. I want to wish you a wonderful spring break. Make sure to continue working on your project with your group. Please reach out if you have any questions or if you need